Greetings. In this video I want to give some information about bell-shaped distributions and the empirical rule. So here I have a bell-shaped curve, and you may recall that the peak of this curve is the mode. Because this is symmetric, the same on the left as it is on the right, and this acts basically as a line of symmetry, we know that for a distribution that this is also the median. And then a quality of a bell-shaped distribution is that this is also the mean. And let's see, what else do I want to say? There's an inflection point where the curve changes. Basically, it's going from this to this, and technically in math speak that's called an inflection point. And in my drawing that happens about right here. And that happens at 1 standard deviation away from the mean. And it's symmetric, so that this is also going to happen on the other side. And so this is the mean plus 1 standard deviation. Now, somewhere along here at the bottom, there's a real number line. This actually goes on and on and on forever in a true bell-shaped or normal distribution. For the purposes of the empirical rule, we can refer to the mean either as a population mean, in which case I would use the symbol mu, or as a sample mean, in which case I would use the symbol x bar. For this illustration, I'm just going to pick one. Let's go with x bar. So here we have x bar. This is 1 standard deviation above that, so I'll say that this is the point x bar plus 1 standard deviation. I'm using a lowercase s because this is sample standard deviation, and this point would be x bar minus a standard deviation. Since I know the width of a standard deviation is basically this width, I can actually add another and even another, and this would be the mean plus 2 standard deviations, and then this would be the mean plus 3 standard deviations. And I'll do the same in the other direction. Here I'm subtracting standard deviations, so I have the mean minus 2 and the mean minus 3. So the empirical rule says that 68% of the data is within 1 standard deviation of the mean. And so, in other words, we could say x bar plus or minus 1 standard deviation. So on my picture here, I'm going to make a note that 68% of my data lies within these bounds. So there's 68%. And 95% of the data is within 2 standard deviations. Of the mean. In other words, x bar plus or minus 2 standard deviations. So between here and here, we'll find 95% of our data. And then the last one, we know 99.7% of the data is within 3 standard deviations. Of the mean. So that would be x bar plus or minus 3 standard deviations. So here we would say 99.7%. So if we are able to calculate the mean and the standard deviation for distribution from some sample data, and where you can determine that there is at least approximately a bell-shaped distribution, we can learn a lot about the distribution in terms of the percentages that are in various ranges. So let's do an example where we actually have some numbers. Let's say that we calculate from a sample of data that the mean is 70 and the standard deviation is, let's say, 8. So we can draw a bell shape for our distribution. We'll put a line down the middle, and that's the center, so that's where the mean is 70. And then I'll draw my 3 lines to the right and 3 lines evenly spaced to the left, and this would be the mean plus a standard deviation, so 70 plus 8, this would be 78. That's x bar plus 1s. If I add 8 another time, let's see, that would give me 86. That's the mean plus 2 standard deviations. And if I add 8 one more time, let's see, that would be 94. X bar plus 3 standard deviations. And going to the left, I need to subtract standard deviations. So 70 minus 8 would be 62. If I subtract 8 again, that would be 54. And if I subtract 8 again, that would be 46. So 46 plus 8 plus 8. All right, so now what can we say? I'll write in my percentages. 68, 95, and 99.7. So I can say that 68% of the data, and if I knew some context, like let's say that these were midterm exam scores. Instead of saying 68% of the data, I could say 68% of exam scores were between 62 and 78, and maybe those were actually percentages in this case. I could say that 95% of exam scores were between, let's see, 54% and 86%. And lastly, 99.7%. So almost all exam scores were between 46% and 94%. All right, so that's just the basic percentages of the empirical rule, but I want to add that we can actually do a lot more with just these 3 percentages. So this is very powerful, so I'm going to add my lines again. There's the middle, my 3 to the right, and my 3 to the left. And this time, I know that, since I know that this is symmetric, and that there's 68% between here and here, well, this is a line that divides this in the middle, so half of 68 is 34, and that would be just for this piece right here. Let's see, I know that between here and here, this piece, that's half of 95, because 95 is from here to here, but I'm just taking half of that. Half of 95 is 45 plus 2.5, 47.5%. So this is 34%. Let's see, there are some other things I can do. Let's see, if this is 34%, and I know that from here over, that's 50%, and from here over, That's 50%. Then I could also say, let's see if I have another marker color. Let's see, what else can I say? Just this piece that I'm going to put in green. In green here, this would be 50 minus 34. In other words, 16%. So that's the green area. We could do the same thing over on the left side and say that this, I'll use a kind of a diagonal or a patchwork. This piece would be 50 minus 47.5, which would be 2.5%. That would be just this little bit right here. So you can get to some different areas just by using the original 68, 95, 99.7, and then the fact that it's symmetric and that this line splits your distribution 50-50. So let's go back to the example where I say the center was at 70, this was 78, plus another 8 would be 86, and this was 94. This value was 62, I had 54, and this guy was 46. So let's say that I wanted to know what percentage of test scores were between 54 and 78. Well, let's see. In that case, I'm wanting to know the percentage between here and here. Now, I know that that's 47.5, and this is 34, so I can just actually add then 47.5 plus 34. This would be 0.5. 7 plus 4 is 11. Carry your 1. That'd be 5. That'd be 81.5%. So I can take these halves, add them together in different ways. Let's see, what would be another example. Let's say I wanted to know what percentage of scores are less than 86. So let's see, I'm going less than 86. Now in this case, I'm going to just mark up here that this is 47.5. And I know that from here over is 50%. So in this case, I'm going to add 50 plus 47.5. So I'll have 97.5, and that's in percent. Let's see, I'll do a final example. Let's say we want to know what percentage are greater than let's see, I've already done 78, so greater than, let's say, 62, no, I think that's, yeah, greater than 62. So in that case, we're looking from here over. I know that this is 50%, that's 34, so that would be 34. That's just this area, plus my 50, 34 plus 50, that would be 84%. All right, so there is an overview of the empirical rule. So we start with just these three basic percentages, 68, 95, and 99.7, but we use the fact that the distribution is symmetric, so this is the dividing line for a 50-50 split. And we can use that to deduce some other percentages. So the empirical rule is very powerful. The fact those three percentages and the symmetry allow us then to calculate some other, several other percentages. So I hope that's helpful. All right, I'll see you in the next video.